Hi guys, welcome back. Today we're on to our 6th episode of the series where we're going to be applying the systems approach to the atmosphere now. So if you remember the spheres from last episode, we're now going to be tackling the atmospheric systems. And just the first thing I want to familiarize you with is the different layers of the atmosphere. So the one closest to us is the troposphere, then we have the stratosphere, mesosphere, and thermosphere. And the two that we discuss the most are the troposphere and the stratosphere, because as you will see, ozone in these two different layers have very different effects. And in fact, on one of them, it's a good thing. On the other one, it's a bad thing. And you'll see what I mean when we get to those sections. So let's begin then by describing the atmosphere as a system. So just like any other, it's got transfers, transformations, storages, and it's a very dynamic system in that it's undergone a lot of changes through geological time. So on the right here, you can see a graph representing the gas proportions in the atmosphere. The majority is nitrogen, followed by oxygen, argon, carbon dioxide, and then small proportions of other gases. And an interesting aspect of the atmosphere is that it's undergone a lot of changes through time, the main one being oxygen concentration. So before the evolution of algae, we really didn't have a lot of oxygen, but because it's able to photosynthesize, when algae kind of became present in our world, there was a huge influx in oxygen as well. So it's a very dynamic system and it changes all the time. So something that the IB have said that they like seeing in exams is when you mention the different thickness of the layers and when you describe the difference in temperature changes in the troposphere compared to the stratosphere. So the way that I remember it is if you go to a really high mountain or like the top of a really tall building, it's colder there. So in the troposphere, when you increase in height, you decrease in temperature. In the stratosphere, it's the opposite. When you increase height, you also increase temperature. So I hope that helps you remember the different relationships. So then, let's see how ozone is different in the troposphere compared to the stratosphere. And this is a huge source of confusion for students. Now, the stratosphere, so the layer that's not the closest one to us, but rather more far away, is the good kind of ozone. It's the one that protects us from the harmful ultraviolet radiation that comes from the sun. And it has very good protective qualities from the harmful effects of ultraviolet radiation. So what typically happens in ozone that's present in the stratosphere is the ultraviolet radiation hits an oxygen molecule or an ozone molecule, and the energy is used to split the bonds between those molecules instead of coming to us. And you don't need to know the exact chemical reactions, the IB specify that, but essentially the ozone and oxygen are converted between each other, and the energy that would otherwise hit us is used in those reactions. So this is how ozone provides those protective qualities for our health. So how do we cause ozone depletion? It's through molecules called chlorofluorocarbons, which are basically very reactive and deplete the concentration of ozone. So what typically happens is sunlight breaks up a chlorofluorocarbon molecule, releasing a highly reactive chlorine atom, which I hope you can see in the diagram below. The chlorine atom is then so reactive that it's able to steal an oxygen atom from an ozone molecule, and thereby overall depleting the amount of ozone that we have. And the biggest problem when it comes to chlorofluorocarbons is that not only are they highly reactive, but they last for a long time once they're released. So the amount of ozone molecules that one single chlorofluorocarbon molecule can break up is tremendous. Ozone depletion is caused by ozone depleting substances, including, and the main one being, chlorofluorocarbons. And chlorofluorocarbons are released from a variety of sources like aerosols, refrigerants, and pesticides, and they disturb. The thing to note is that ozone naturally goes from ozone to oxygen in a natural cycle. The problem is that we limit the regeneration part of the cycle and render it a non-renewable resource. And why is this a bad thing? There are a variety of effects due to ozone depletion, all of which are the result of really dangerous high energy ultraviolet radiation hitting us and having access to living systems. So a main one is cataracts and blindness because it damages our retina and the retina of other animals. Skin cancers due to cell mutation. It also causes suppression of the immune system. And it decreases the population of phytoplankton, which are UV sensitive. And they are in charge of a lot of the oxygen proportion on Earth. So the effects are not only to humans, but all of kind of the living system. So let's move on now to talk about tropospheric ozone, or the bad kind of ozone. Now, first, I want to make clear that you guys understand that the depletion of ozone on the stratosphere has nothing to do with climate change. They're completely separate issues that a lot of people get confused. I used to as well. But those are not related in the syllabus. So the tropospheric ozone is essentially an example of a secondary pollutant, where a primary pollutant is a chemical that is active on emission. A secondary pollutant is when a primary pollutant either reacts with another element of the atmosphere or undergoes some kind of chemical change. And in this case, it's oxygen molecules reacting with oxygen atoms from nitrogen oxide. So the secondary pollutant formed is what leads to the bad kind of ozone. And you can see in the image below an example of a smoggy day, where essentially there's a lot of pollution concentrated in this lowest layer of the atmosphere. And smog, or photochemical smog, is a complex mixture of primary and secondary pollutants, the main one being ozone. And the reason we call it photochemical smog is because these reactions are driven by sunlight. And the effects of tropospheric ozone include damage to crops, so their chlorophyll and plants, so essentially decreasing biodiversity. They irritate eyes and lungs, causing respiratory problems. They're very highly reactive on fabrics and rubber. And they can basically result in economic losses because of tourism being affected, the costs of cleanup, the costs on healthcare. So all of these are why tropospheric ozone is a problem. And the severity of the problem varies according to the specific topography and climate and population density of the area that you're talking about, and also related to how much that population relies on fossil fuels as well. So hopefully you guys are able to connect what we've talked about in different episodes together and see that an environment or a population that relies more on renewable energy resources would decrease the proportion of smog in that way. And the final process I want to tell you guys about is of acid deposition. And they used to call this topic acid rain, but they realized that it didn't encompass the different consistencies that acid deposition can exist in. So it can be acid rain primarily, but others as well. And it's a result of combustion of fossil fuels. So this is a culprit we commonly discuss, which produces sulfur dioxide and oxides of nitrogen. And through becoming a secondary pollutant, they can be converted into wet or dry deposition. So in the diagram below, you can see that from an emission source such as a factory, they can undergo chemical changes driven by sunlight. So you can see that it's a photochemical reaction as well, and essentially form acid deposition. And the impact on it also has impacts on living systems in the built environment. A big problem is on aquatic systems because many aquatic organisms cannot stand a low pH below 5 or 4, which is highly acidic. So it disturbs those ecosystems. It can cause damage to leaves and damage to chlorophyll and interfere with photosynthesis as a result, so reduce growth and primary productivity. And it can also cause respiratory problems like bronchitis and asthma. And you can see in the image below the effect on built systems. So you can see those statues having been completely destroyed by the acid deposition. And that's all I'll tell you guys about regarding topic 6. I hope I have given you a quick overview, at least, on the different processes that they discuss here. So yeah, as always, make sure to check out our website. But I will see you guys in episode 7.